Good morning, friends. Today I am going to explain an interesting topic in operating systems. Before starting the topic, let me tell you a small cutie story. I hope you enjoy this story and try to guess what topic I am. Romeo and Juliet loved each other deeply and exchanged their hearts. However, their families did not agree to their marriage. Because of this, they could not live happily together and eventually both died. If they want to live happily, they needed their hearts again and family approval. But since both were dependent on each other and no one helped them, the situation ended tragically. If this situation happens between two persons, we call it love. But if the same situation happens between two processes, we call it deadlock. What is deadlock? Deadlock is a situation in operating system where two or more processes are waiting for each other's resource and none of them can proceed further. In simple words, when processes keep waiting for resource held by each other and cannot continue execution, it is called deadlock. Let us take a simple example. Neha is using a blue pen. Bhargavi is using a black pen. Neha needs black pen to complete her essay. Bhargavi needs the blue pen to complete her essay. But neither of them is giving their pen. So both are waiting. No one can complete the essay. This situation is called deadlock. Consider two processes. Process 1, process P2, process P1. Situation: P1 holds resource R1 and requests resource R2. P2 holds resource R2 and requests resource R1. Now P1 is waiting for P2, P2 is waiting for P1. No one released the resource. So both processes are stuck. This situation is called deadlock. Four necessary conditions for deadlock. There are four necessary conditions. Deadlock occurs only when these four conditions are present. Mutual exclusion. Only one process can use a resource at a time. Example, one pen can use it by only one person. In OS, printer memory. Files cannot be shared at the same time to both. So, this is called mutual exclusion. Hold and wait. That is the next condition. A process holds one resource and waits for another resource. Example, Neha holds blue pen and waits for black pen. In operating system, we say P1 holds R1 and waits for R2. This is called hold and wait. And under condition, no preemption condition. Resource cannot be taken forcefully from a process. Example, teacher cannot take the pen from Neha and give it to Bhargavi. In OS, we say resource cannot be removed from a process automatically. They must release it voluntarily. This is called no preemption. And the last condition, that is circular wait. Processes form a circular chain and wait for each other. P1 waits for P2, P2 waits for P3, P3 waits for P4, P4 waits again for P1. This creates a cycle. This is called circular wait. Now I would like to discuss about deadlock preventions. What is meant by deadlock prevention? Deadlock can be prevented by removing any one of the four conditions. Yes, am I correct? Method 1. Remove mutual exclusion. Allow resource sharing. Example, use shared printers or shared memory. Method 2. Remove, hold and wait so that deadlock can be prevented. Process should request all resources at once. Example, P1 requests R1 and R2 together. Method 3. Remove no preemption. Force the process to release resource. Example, OS takes resource and gives to another process. And method 4. Remove circular wait. P1 should use R1 resource, after that R2 resource, after that R3 resource in order. No circular waiting occurs if we apply this. What you learn from this class? By listening to this class, you learn three important things. What is deadlock? What are deadlock conditions? How to prevent deadlock? Advantages of deadlock handling: better resource management, efficient process execution, system stability. Avoid system crashes. Disadvantages of deadlocks. What are the disadvantages of deadlocks? Process stop execution. Processes are not completed, which means tasks are not completed. They are in incomplete state. System performance decreases. CPU idle. System may hang. And finally, deadlock is a dangerous condition in an operating system where processes wait for each other and cannot proceed. To avoid deadlock, remove mutual exclusion, avoid hold and wait, allow preemption, prevent circular wait. If we control these conditions, the system will run smoothly and efficiently. Thank you. Bye bye. See you in the next video. Comment me if you have any doubts. I hope you understand this topic very clearly. If you have any doubts on any other subjects, comment me below. I will explain it in easy way.